Welcome everyone to the 16th video in a series of videos on solar and wind energy estimation and forecasting application developed in MATLAB. I'm Kiran Gaikwad, the developer of the application. I have a Masters of Technology in Power Electronics and Power Systems from Sardar Patel College of Engineering, Mumbai. I'm currently working as a Junior Project Fellow at GERMI, Gujarat Energy Research and Management Institute under Dr. Sagar Kumar Agrawal. In this video, we will have a demo on the ANN forecasting app. And as we know from the previous videos that the ANN forecasting application is a part of the forecasting application structure, and this is the main GUI interface for the forecasting application. And in order to start the ANN forecasting app, we'll press this button. Okay, we'll minimize this window, and this is the main interface of the forecasting application for using ANN, is artificial neural networks. So we will be going through a workflow and we will be forecasting weather variables in this demo, and there are 4 steps that we have to follow. Step 1 is the input data which we will require for learning. Step 2 is creation of the artificial neural net. Step 3 is the training of the artificial neural net and estimation of the training, and step 4 is the forecasting and output file extraction into an Excel file. So let us start. For this demo we will be using a multi-year file spanning from November of 2014 to September of 2015, and if you have a single year file that it doesn't change from year to year, that you don't have multi-year fields into your file, you can choose single year, but this is not the case with us now. So we'll be choosing the multi-year file, and we have 3 modes which we can use for separation of that input file into appropriate input and target files, which I will explain to you in a while. So for this purpose, for this demo, we will be using the mode 2. So we are having 3 modes at our disposal in this application, and we will just go and look at the input file structure. And at the left, this is the ANN input file, which spans from, so I'll just describe the columns to you. Column A is day, column B is month, column C is the year, and column D is the time in decimal, column E is the wind speed in meter per second, column F is the temperature in degrees Celsius, and column G is the GHI, that is global horizontal irradiance, in watts per meter square. So this is the file which we will use to train our ANN model. So what will happen? So why do we have these 3 different modes? So in mode 1, what happens is this file will be divided into 2 subfiles inside the application as an input file and a target file. So in mode 1, the input file will be using these 4 columns, and the target file will be the weather variable columns. But in mode 2, we will have 7 columns, and first 4 will be the date time signature columns, and the rest 3 would be the variables, the weather variables, one step behind the step we have to forecast for. Okay, and in mode 3 we will have more 3 columns over here. Those will represent the rate of change of each of these previous lagged values over here, and we will have 9 or almost 10 columns as an input, and in every case the output, the target file, would be 3 columns. Okay, 3 columns of the weather variables. So this is how we use the 3 modes, and for our work analysis we will be using the mode 2, in which we will have the input file as 7 columns with 4 columns of the date time signature and the 3 columns of the previous weather variable information. Okay, and in modes 2 and 3, when we hit the forecast button, we have to supply it with another file. Okay, because we cannot create that file as we require, or the targets depend upon the previous values, so we have to input this file as well. This is nothing but the file from 1st of October 2015 till 29th of October 2015, and each, like, if this column is being used as an input, then we will have forecast for the second column. Okay, the second row, I'm sorry, this field is used as an input, then we will have an output forecast for the next column. So mode 1 helps us in creating an ANN which is independent of the previous values, and modes 2 and 3 are dependent upon the previous values. Okay, so let us start with our workflow. So we have selected the multi-year file, mode 2, and we have to select the input target file, and we will select it. It's in GERMI with the publisher over here. So this file, okay, open. And the step 2 is creating the actual neural net configuration, and we can select from these 3 types of neural net structures, that is the fit net, the feed forward net, and the cascaded feed forward net. For this workflow, we will use the feed forward net, and now we can design the internal hidden layers of this structure. So we can input the number of hidden layer neurons over here, and if we have multiple hidden layers, then we can just comma separate and enter the number of neurons of the second layer, and if we have 3 layers, then we can enter the third layer like this. But for our workflow, we will be using a single hidden layer with 5 neurons, and then we have to select the training function. We can use one of these 12 training functions which the artificial neural network toolbox of MATLAB provides us with. So we will be using the first one, and then we can view the net using this button. And as we can see, there are these inputs, the outputs, the hidden layer which has 5 hidden neurons, and it's okay, we can go ahead. So now in step 3, we will be training the neural net. So in training, we can train multiple neural nets using the same configuration. I'll tell you why we do this. And let us say we have to train 2 neural nets. Okay, so let us start to train. So we can press train network over here, and the training will start. It has started. So why do we require to train multiple nets of the same structure? This is because the neural networks consist of neurons which have weights and biases, and these weights and biases are nothing but numbers which are populated using the training algorithms. So whenever a net is created, it is populated with some pseudo-random numbers, and this initialized state of the neural network structure can affect the output. So in order to mitigate that effect of the pseudo-random numbers and the weights and biases of the neural net structure, we have to train multiple nets. So this is just for demonstration, it's 2, but we can do n number of nets and train them simultaneously, and then view its performance, and then select a network which has been trained as per our desire. Okay, so the training is going on. We have to wait for a while. It will take some time. So it's going on. So what we have actually done over here is we have created a workflow and we have automated the workflow, and we would like to do more research around this workflow and improve it as we try and understand more and more about the use of artificial neural networks in predicting weather variables. And as and when we come across something different, we would try and incorporate that into this application so that it is repeatable. The process is repeatable. Up till this point, what we have done, we can see now this is the second net which is being trained, and I think it's done. Validation is stopped. We can close this. And now we have to check the performance of the neural nets. So we will hit performance plots, and this is the performance plots GUI. We will plot using this plot button, and we will see the net number which has been the plots of which are displayed on the screen over here. So let's hit plot. Net is 1, and we have these plots coming up. We will have 4 plots for understanding the training which has been done, how effective our training was. And the most important thing over here is this R value, and that is 0.96 for this net 1. And as we can see, there is a good follow of the train, validation and test lines over here. And we have some errors, a histogram, and a training state plot. Okay, so now we will have to look for the next net. That is, next we'll click on next 2, and it will, all the graphs will be repopulated, and we have 0.96326. Let us check net, and it will again repopulate it to 1, 0.9636, 0.9638. So I think this one is a little bit better. And then you can make your decisions upon how you desire your training to be, and then we can close everything using that, and we will say the best net which we have trained is net 1. And then we will go to step 4 for forecasting and output extraction, and over here we will put in the forecast year, which is 2015, the resolution of the file, that is 15 minutes, and start month is October 1 and end month is October, and the day is 29, and then we hit forecast. So this is the period for which we want to forecast using our trained ANN model. We will hit forecast. It will ask us for a file because we are using mode 2, and the inputs required by that model require the previous values of the weather variables. Hence we have to input a new file. It is in MATLAB programs, ANN forecasting, updated over here, input forecast, modes 2 and 3, open. And now it has started to forecast. We will have a new Excel files with the forecasted values of the weather variables created in a working directory over here. And as we can see, forecast ANN mode 2 file has been created over here. So we have just completed a forecasting workflow using our application, and I would like to show you some of the results which we have obtained by using this application. And this is an Excel sheet. There's a dashboard, Excel dashboard, and we are looking at the energy output. Like, this is the actual energy output which we have computed after using the forecasted values from the forecasted weather variable values from the ANN application by inputting those values as inputs to the solar energy estimation application and then generating the energy output. Okay, so what we are looking at over here is day 10, that is 10th of October, for the same workflow, mode 1, fitnet. We change it to fitnet. Then we have hidden nodes. How many hidden nodes? 5. So what we can see over here is the orange line and the orange curve represents the forecasted values, and the blue curve, that is the real values of the plant. So we are quite near, I guess. Not so good, but as and how we get more and more data and the ANN models are trained more effectively, we can reduce this error. So if we increase the hidden layer neurons by more 5 numbers, that is 10, then we have a closer approximation. At 15 we are more close. Okay, now let us see how mode 2 reacts to this. We'll select it to be 5, mode 2, and mode 2 we can see that we are able to follow these nicks over here, but they are still offset. We are now overestimating it. We are able to gauge the curve properly, and in mode 3 we are able to do this, and we can see in hidden layers of 10 like we are able to do it not that properly, but we are still able to follow for this thing the mode 2 and hidden layers 15. 15 is the best one, I guess. So this is how we have done it, and as we can see, as the number of hidden layer neurons increase and the number of hidden layers increase, we are coming to a more closer approximation of the forecasted values. Okay, so that's about it. So this application is useful for developing ANN models with the flexibility of 3 modes of operation, 3 different net types, that is the fit net, the feed forward net, and the cascader feed forward net, and we can use 12 different training functions, and we have an infinite possibilities of hidden layers, like we can have more than one hidden layer with any number of hidden neurons. And we can do all this by just click of the buttons. That is the usefulness of this application. So what is the next step is to have more data, train models, and look for that perfect optimized hidden layer structure, the good exact hidden layer structure which can give us very good approximations. So some more work has to be done in improving this. Thank you.